Hello, this is kind of a knowledge share, not totally a deep dive, but I'll provide some links if this can help others who may be interested and or curious about the same kind of thing. But I'm looking into what it would take to use a distributed cache in a .NET Core 2.0 and a .NET Core 1.1 application or web app, shall we say. Um, and as far as that goes, the cache itself would be, you know, ultimately hosted in the AWS cloud. And what I wanted you to see was through my portal, there is a service in AWS called Elasticache. And Elasticache itself allows you to create a distributed cache in the cloud so that all of your applications on their EC2 instances and such, that they could go and take advantage of really fast caching. Um, there's all kinds of videos on Elasticache for AWS. Reinvent videos are great. There's other ones, A Cloud Guru, a Plural Site, Linux Academy, and all that. So I'm not really going to go into a deep dive, or other than just letting you know that in Elasticache, they basically allow for you to create caching by using two very popular caching engine. One is Memcached, which is older, and the other is Redis, which stands for Remote Dictionary Store. And with Redis, when you go ahead and you can create a cluster up in the cloud, you can set multi-availability zones. I'm not going to get into all that kind of stuff because that's kind of outside the scope of this. But the long and short of it is Redis is pretty much the de facto recommended caching engine to go with up in the cloud. Memcached is a little bit older. Redis supports, and please feel free to jump onto the comments and correct anything I might be saying wrong, but Redis supports complex objects as values, things of that nature. Redis also supports up to 512 megabytes of value stored by the key and all that, whereas Memcached supports up to 1. The long and short of it is the things that I've read and the recommendations I'm seeing is 99.9% of the time go with Redis. So having said that, basically I'm going to give a demo that shows how you can basically set up Redis in a ASP.NET Core 1.1 and 2.0 project. The path I chose may not be the best path, but it's working, and I totally welcome anybody else's comments and suggestions and all that. And I don't claim to be an expert in this. It's just this is just basically a result of a day's worth of research on my part. And you know how it is, a developer, you know how that goes. You look into something, you come up with some things, you get a proof of concept, a spike going, and then you may find out later on from other very helpful people on the internet, or the things of that nature, much better ways to do it. So a disclaimer, this way is not, I'm not coming out there and saying that this is the way you have to do it or anything like that. This is just the result of some of my research, and I'm hoping maybe that this can help others. So what I did was I basically downloaded Redis onto my machine. So I went to HTTPS Redis.io. I downloaded it for Windows. It can run under Linux and all that kind of stuff. And basically, when you download it, it creates a directory, and I set my path basically to look for the Redis application itself. But basically, you can start up the Redis server by typing in Redis-server. And so I set up the Redis, or I started up the Redis server. I'm sorry, I lost my concentration there. My phone was ringing. So when you start up the Redis server, basically you get this console log and all that. I won't get into details on all the really cool things you can do with Redis. For that, I'd highly recommend, on YouTube, if you do a search for Redis tutorial for beginners, there is this 2 hour and 8 second video called Redis Crash Course. I took it. I found it really excellent, and this gentleman, kind of walks you through Redis basically in a shall we say, a command line way. Not sure why I'm getting this video. I was kind of hoping. There you go. As you can see, he's using Redis itself to from the command line, so you can do it that way. Or I should say, I'm not really interested in using the command line for Redis. Basically, I'm looking at an ASP.NET Core application that will allow us to cache a whole bunch of items. So normally we would have a repository that would it's using Entity Framework, it's using DB context and going out and grabbing various things. As an example, I'll set up something like content. Let's just say, for example, it's a CMS and you're displaying content and stuff to your web app, and you don't always want to go to the database to grab the content every single time. So that's a good candidate for using Redis and caching and all that. So I'm just setting up an example or a spike here to show you that. So I'm not going to get into any of these commands here. It's a really good video, but it shows everything to you from a totally different angle. But I wanted to leave that out there for you. So you would download Redis, and then you would start up your Redis server. Once you have the server started up, you're basically good to go. You can hit Redis on port 6379, and the next question is, if you're doing C#.NET development on ASP.NET Core 1.1 and 2.0, where do you start? So I created a very crude example up in GitHub, or I put these two solutions up in GitHub, and I'll include a link at the bottom of this video and stuff like that. And I got to warn you, the code is not the prettiest, but it's a spike, it's a throwaway. But I did want to show you that it does work. I created two separate solutions. I called one like Redis free one, and I'll explain that to you in a second. And the other one was MS Redis 1.1. So the difference between the two is one works on .NET Core 2.0, which is this Redis free one, and the other one works on .NET Core 1.1. So I kind of took a somewhat of a backwards way. When you're learning something, you try various things and you realize, oh darn, maybe I shouldn't have started out this way or that way. But the Redis free one actually works with .NET Core 2.0. So if you're developing .NET Core 2.0 applications, I think this is really a cool one to use, because what this is using is it's using this free Stack Exchange Redis library that's out there on GitHub. So let me just bring up this GitHub page for you. So basically it's a NuGet package, all that kind of stuff, where you can include it in your project. I will tell you, as you're reading up on this, it'll recommend some of these sites will recommend that you use stackservice.redis, which really is slick. I mean, I wrote a proof of concept for that, but I didn't include it here. That allows for templating, generics, things of that nature. The only problem is, when you start using it all, you're going to get some exceptions thrown saying that it requires a commercial license. And so that's kind of a paid solution. You need to have a license, you need to pay for a developer license and all that. So I was looking for one that's free. So the other one I came across was this stackexchange.redis, and it seems to be, pretty solid. So I brought it into this project, and I kind of did some research on the API. I discovered when I pulled it in order to support complex objects as your values, you have to install stack exchange redis.extensions. So there's two things that you have to do in order to get it to work with the .NET Core 2.0 application in order to support objects, and I'll show you this in the code in a second. The other thing to keep in mind is I tried to, shall we say, downport to .NET Core 1.1, and I didn't have much luck with it. It turns out that this solution, it's a great library and all that. It's using some things, namespaces and such, that don't exist or could not be found in 1.1. So, I tried spending a few minutes trying to change some of the namespaces and use some different things, but I stopped right there and basically went with a different approach for 1.1. So I'm not saying you couldn't port this down to 1.1, but I have another alternative for you if you don't want to go ahead and do this port. But this is a fantastic library, the extensions. So what I did, I noticed in my solution here that I was not able to find this stack exchange redis.extensions in my NuGet when I tried to go into manage NuGet packages. So what I actually did, and there might be a better way to do it, is I cloned this repo, brought it up under Studio, and I compiled it under 2.0, and then I just basically grabbed these two DLLs, which you'll see here, which is like stack exchange redis extensions binary.dll. This is for binary formatting. This allows you to store complex objects in your cache as well as core. And there's other projects inside of there, but these were the only two that I needed. So I just copied them into here after I compiled them, and I just went ahead and just added it as a reference, basically for the extensions under assemblies right there. So this is a .NET 2.0 project, and enough yakking on my part. So, it's like one of my first videos and such, so I'm afraid that I'm kind of rambling on. So I'm going to go ahead and run this and then show you some of the code or how to start this up and stuff like that. So I am going to, whoops, what is that? Okay. Turns out that I had my other solution running, so I had to close that. Whoops. Now let me go ahead and start this up again. 1 second here. All right, bear with me here. Sorry about that. It never fails when you're doing a recording. Basically, I'm going back and forth between the two solutions, and both of them are using the same port. So I forgot that I had the other solution up that was locking this port. So when I tried to debug this one, that port was already in use. So I just kind of had to make sure that it was going to time out and gracefully close its connections and stuff like that. So this example, I purposely did not make a UI and for both of these, and rather what I did is I'm using Postman, one of my favorite tools, and I have a collection, a Postman collection that I included in my GitHub that you can basically import into your Postman. If you haven't tried Postman, I'd highly recommend downloading it for Chrome. It's a killer tool. Allows you to test your REST endpoints and all that kind of stuff. So basically, I started up this application. This is .NET 2.0. And what I wanted you to see here is I got like 12 commands here. So this particular application is going to allow you to do some CRUD operations against the Redis cache. And if we take a look at the, basically the Solution Explorer, inside of the controllers, I have a home controller and I have a widget controller, and I'm kind of using these as kind of like an API, REST with REST endpoints and stuff like that. So I got all kinds of methods here to add a widget, I'll explain the seed big data, to remove a widget by ID, to get an existing widget, to print out all of your widgets and stuff like that. What I wanted you to see, though, is Now my home controller, I should have probably called it content controller, because what I'm doing is I'm simulating content from a CMS, for example. So your content, like Umbraco would be a good example, but your content would have an ID as its key. And then text, this could be like a massive big chunk of HTML, for example, associated with ID. The way Umbraco stores things is they give you an ID and a text. So if you can visualize, maybe you have 10,000 different types of items and all that that you query from Umbraco or whatever. And whenever you're displaying a web app or a website or whatever, the idea is you may want to start caching these items instead of always going to the database to pull them. So I have this simulated thing called content. This text can be up to 512 megabytes potentially if you're using like Redis and all that. So that's a lot of HTML there or whatever. And then I just created something. I named something like a widget, for example. So I have two controllers. So I just wanted to basically prove that you can, maintain as many quote unquote databases in Redis if you like. It's all about the keys, and like I said, it's nothing pretty. But so what I've got right here is when you start up the website, um, you know you can use Postman to import the collections. So I included a JSON file, so all you really have to do is import and point to the file, and then once you do that, you'll get Redis demo with all these different commands that you can run. So they're pointing, to this basically this URL. Ignore this kind of stuff. This is carryover from the previous runs in here. But what I wanted to show you is, for content, if I wanted to take a look in the cache right now, I'm just basically saying, get me all the content items we have out there. We have none. And then if you want to do the same for widget, you can select that and implement it. It says, get me all the widget items. We have none. So I just wanted you to see that we don't have any in there. So now I have another thing that allows you to say seed content with data. And what this basically is doing is this is just saying, create 20 items starting with key 10. So if you say send, basically it's, but believe it or not, it's actually called this home controller behind the scenes to create 20 dummy items. So now if I say content get all, there's our 20 items if you look here. So basically this is all going to and from the cache. Seed widget with data, it's the same thing except for it's just widgets. So it's the same concept. The seed big data, basically I was testing out, how much data, so like for one item, how much space we want to allocate. So I'm just saying create an item out there with ID 100 and give it basically a 1 megabyte content right here. So we have 1,000,000 bytes. So create an entry with ID 100 and 1,000,000 bytes and call it seed big data. So basically, it's hitting my breakpoint there. As you can see, I'm just creating 1,000,000 items with the letter I there. It doesn't really matter how big it is, but as you can see, it went really fast. Now you can say content gets specific, and this allows you to query by a given ID. So I want to see 34. And I don't really have anything out there for 34. Let me query the item that I had, which is 100. And so now it's actually going to the cache, and it just pulled back that 1 megabyte item. So, there's other things you can actually add a content item. So if you click on this, there's your post command. And if you go to the body, I'm just saying for ID number 8, just add this item. So you could just say, test this. And I'll go ahead and send it. And now I'll say content get specific. And I want to look for number 8 here. Oops. The Postman kind of remembers the last command that you had, which is, you know, um, a good and a bad thing. So I just got item number 8 right there. So I could say content get all again. So, you know, because we have that big item with 1,000,000 bytes, that's probably why it's taking a little bit longer. I can delete an item. I'm going to get rid of that one that we had out there, basically with 1,000. And now if I say get all again for the content, it should come back and it's returning all the items right here. It stops at 29. So like I said, it's going through all the items here. So let me show you some of the code, and I'm really sorry that I'm rambling on this. From a coding standpoint, you know, we've got this home controller and the widget controller, and they both pretty much support, pretty much have the same methods inside of here. It might be a little bit hacky on how I'm creating the keys, you know, so when you give it an ID, for example, when you say this 27 on a get, for example, um, behind the scenes, what it's really doing is it's looking for this. It's basically prepending content underscore and passing 27 in here. So in other words, when you add an item, what I'm really doing behind the scenes is I'm generating a key with your ID, but I'm prepending it with content underscore because that's what the home controller is all about, is maintaining content items. And then the widget items would be maintaining, you know, widgets. So I just wanted you to see that this is how you could kind of like separate some of your data out. I think Redis also allows you to specify different instances and or database repositories in Redis, but I haven't really quite figured that out. If you do, please, you know, post something down there for me. So assuming that you're running up in the cloud, AWS, you know, all you really would need to change, the way I understand it, is the endpoints. Instead of localhost, it would be your AWS URL or endpoint. So with Redis, by default, everything's on port 6379. So using that Stack Exchange library that I imported in with NuGet, um, you know, this is kind of the way things look like. They have this connection multiplexer. So you initially it would connect to your cache here, and then you would create a cache client. There's various ways you can do this in a .NET Core application. You could create a singleton, you could inject it and all that. And I'll show you that in the next example. But in the interest of getting something going here, you know, I just had a controller and I'm just putting everything in the same source file. This is not how I would do it in a real world application. This is just proof of concept. So anyways, if you want to, you know, here's an example of what happens when you do an ad. So when you click on content ad, for example, it takes, you know, you pass this body, it's just going to basically call this method and it's going to go through the regular MVC model binder, create a new entry. What I wanted you to see is because I'm using the Stack Exchange Redis extensions, it allows us to basically put a class as our value. So it's going to serialize it and stuff like that. And so, you know, I'm just getting the cache client right here, which is, you know, going out to the Redis Exchange. I'm sorry, yeah, the Stack Redis Exchange library. And it's just getting a connection to Redis and it's going to add it. Basically with this key. You can also give it a TTL, which is a time to live. So the idea behind this is add this entry and keep it alive for 10 minutes. You know, after that, you know, the next time you try to do a get on that key, it won't exist. So there's a lot of flexibility. There's all kinds of opportunities for your production app or whatever, you know, where you can add expirations. You can do it at the key level, or whatever. So I won't go into too much more detail here. As you can see, there's a remove. So it's an example. You've got the key. This is how you would remove the item. This is how you would get a specific item. The get all, this is how basically I'm just saying get me all the content out there. So what I'm doing is I'm just grabbing the keys by a search. And once I get all the keys, I can just basically say, here we go, grab all the items with the key here, which is a collection. It's an IE enumerable. So we're passing all the keys that we have and then just order by the key. So that's, basically what allows us to iterate through the content collection that you see here. And that's really it with this example. So that basically was a solution, if you will, for .NET Core 2.0. But it turns out that, if you got a 1.1 application, which we also have, that particular solution is not going to work unless you try to port that stack library, the Redis. And I'm not even sure how much effort that would be. Maybe the original author would know or whatever. But, like I said, when I tried to compile it down to 1.1, I was getting a whole bunch of errors and all that. So what I did was I figured, okay, well, how can we go ahead and do something for .NET Core 1.1? And what I found, after doing some research and stuff like that, was Microsoft itself has an API, if you will, or a namespace. I found out, it's not as, shall we say, robust as the Stack Exchange one that I just showed you, but it does work for .NET Core 1.1, and it's the Redis cache that they have, and it's in the Microsoft Extensions Caching Redis namespace. And I did find out, they do support a .NET version 2.0. So technically, if you want, you could just bypass everything else and just go with this, for both your 1.1 and 2.0. But like I said, I think that other library was really, really cool. And it'll work basically with Linux or anything, non-Microsoft stuff that you're using too. So it's a really good, the Stack Exchange Redis, on a 2.0 project, I would probably use that. But with 1.1, I went ahead and used this Redis cache thing. So there is some example here, and I included this in the solution that I have in GitHub. It shows you, like when you create a 1.1 project, it shows you how to, install it. So you actually have to install this as a NuGet package. And what you do is in your startup for this, for 1.1, you would have to go into your configure services, add this option here, change this, whatever your instance name would be. And I think this might be how you can specify different Redis repositories. I'm not quite sure, but you might be able to have multiple Redis instances off the same port. I haven't got that far yet. Somebody please chime or add comments to that. So in other words, you just add this in your configure service, say, distributed cache, um, and then you're pretty well good to go. If you wanted to set other types of options here, you can, inject this here. So as an example, you can inject a global thing if you want, and that's all fine. I have this solution, is called MS Redis 1.1. I will confess I only put one controller in there instead of two. So I basically took this Redis free one for .NET 2.0 where it had the home controller and the widget controller, and I just basically took this home controller and placed it into here and changed this to use the Microsoft API. Oh, and by the way, switching gears ever so slightly, I apologize, I forgot to mention this. Back in the 2.0 solution, which is where I'm at right now, in the startup class, I forgot that you have to, in configure services, you do have to add this services add singleton kind of thingy in order to use the Stack Exchange Redis client. But once you do that, you can inject that, if you will, into your controller. But I just wanted to mention that. So switching back over to the .NET Core 1.1 application, which is where I'll just stay right here. Um, I'll go ahead and run that, close down the other one, because this one's using the same exact port, which is, the way I set it up, which is 55261. That way you can still use the same Postman to test this out. You can compile, start it up. This might be a little bit boring by now, but I just wanted to kind of let you see that, it's going to find that cache, and it's going to, so it just started it up there. And let's see what we got here. I am going to go ahead and just add an item. So we will add content. This only supports content with the 1.1 application, doesn't support the concept of a wizard. So I'm going to add ID 18, and then go ahead and send it there. Now, if I say content get specific, and I choose item number 18, you can see that it pulled it back. Only this time now it's going into the 1.1 application. And just to prove that, I'll just go ahead and set another breakpoint inside the get method right here. And we'll go ahead and run this again. And as you can see, the breakpoint's been hit. And so it's pulling in, the key right there. And it basically pulls that in. So showing some of the differences here. With this one, like I said, you would go into your startup, and you would add this add distributed Redis cache thing in the home controller. If you want, you can add a widget controller or something if you're just playing around with this. There are some differences. What I did was, here's my content class. So it's a complex object. With 1.1 and with this Microsoft thing, they actually have, if you look at their API, they don't have that many methods. And as a matter of fact, they're missing a method. But I wanted you to see that, basically when you call get on a key, they're always going to return you back a byte array. If you call set or set async, they're always going to expect you to pass in a byte array. So in order to store complex objects, you're going to have to serialize and deserialize your content going in and out. Or this could be any complex object that you have. And like I said, this is a proof of concept, so the code here might not be the cleanest, but here's a complex object, and then we have a deserialize method. And also there is a serialize method right up here too. Which, so when you're going into the cache, you're going to want to serialize your object. When you're coming out of the cache, you're going to want to deserialize your object. And unfortunately, each each object type is going to have its own serialize method, as you can see here, an ID and a text. But I also have another method here called serialize, which I just noticed, but it's the same thing. So we're using dependency injection with .NET Core because we set it up in the service. So when the home controller starts up, we get an instance of this distributed cache coming in, setting up the local cache, which is this distributed cache. And this part I thought was pretty cool. Actually, I just noticed I don't need this thing right here. Sorry about that. I was playing around with another experiment. Like I said, it's a throwaway project. You could set up some options to your cache, and what I've got going on right here is a nice feature. You can expire your objects, if you will. And this is basically the set sliding expiration. Just says, hey, expire a particular item if it has been more than 30 seconds since you last accessed it. It's a time span object, so you could put whatever you want. If you want it to expire in minutes, and you just say from minutes, or if you didn't want the option itself, just don't include it. Plus, you can do set absolute. So there's absolute expiration, so there's things that you can look at. But anyways, here's what happens when you add content. I'm calling the set async method. Here's the key. I'm calling this content. I'm saying serialize it, which basically turns this object into a byte array, because this Microsoft one wants you to store your objects as byte arrays. And then here's that cache options, which says expired after 30 seconds of inactivity. Granted, this is an unrealistic time frame. I was just playing around with it, but you get the gist. I think you can also not even pass the cache options in if you don't want it to expire or whatever, or use. I think there's a default. I'm not sure. But here's the thing. You don't have to pass the same cache option with all these methods. You can create separate cache options with each one of these. So in this method, if you want it to expire after a day, you can create another cache options object and set the time to be a day. This one, you can set it for a few minutes. So it doesn't all have to be the same. So let's see what we got here. We got sets here. We have our get. So this is how, when you're getting an object from the cache, you want to get the byte array, and then you want to deserialize it back out to your content. So that's what's happening right here. Just wanted you to see that. And what I did notice, which doesn't really exist, is a method to get all of your items from the cache. So I kind of put a not found, cannot find an implementation. Didn't have time to look at how you would do something like that. But granted, I think in that case, what you could do is you could store another item that has all of the keys, and then you can store that in the cache, and then you can pull that array of keys out and then traverse this given set of keys with that, so you can get all of your items that way. So there's several ways to find a solution there. I'm trying to think if there's anything. Oh, I did want to show. I do have a GitHub page that basically has both of these solutions up, in case you're interested, if it'll save you some time. On my GitHub, which I can provide a link if you're interested. I've got the Redis.NET Core 2.0 example and the Redis Core 1.1 example. And what you're going to want to do is pull them down. If you're using .NET 1.1 in Studio, go ahead and pull this one down. If you wanted to try in 2.0, you can use the other one. The key is also, I'd highly recommend that you install Postman as a Chrome extension. So you can go into Chrome and install Postman. And once you do that, you could take this Redis demo Postman file .json, which is kind of cryptic, but it's got all the commands inside of here. And you can just go ahead and say import, and then you can drag that file in here. And what's going to happen is it'll create this collection right here, this Redis demo, and it'll create these kinds of methods here that you can go ahead and play and test this API. So I think that's it. I'm sorry for rambling on at points. I hope this helps anybody else who's thinking about looking at Redis or what it can be used for and things of that nature. And again, Redis has got lightning fast millisecond response time, and it's one of the preferred engines in the cloud that you can use and stuff like that. So, and again, my understanding to move any of these applications up into the cloud, you don't really have to change much code at all except for just your endpoints, and like right here, make it an AWS URL and make sure you got your instance in the cloud accessing it, and then maybe the instance name. But other than that, all the other code remains the same. Or you can just host Redis on-prem on some other server that you have, running, a QA server, production server, or whatever. As long as you've got the IP address and or the domain name or whatever, make sure that Redis is started on there. You can access its port, and then you got yourself a distributed cache for your web apps and or your console apps and or whatever other types of apps, and they can all share the same cache. So I hope this helps. And I apologize for my rambling and maybe my bad language and all that, but my intent was purely to help. So you guys have a good one, and thanks for watching. Take care. Bye-bye.